Morning, guys. Today we're going to take a look at pages 15 and 16 of the Unit 8 Classwork packet. Today we're going to take a look at a shape called a trapezoid. Now, a standard trapezoid, alright, really only has one defining characteristic. Yes, it's a quadrilateral, but what makes it a trapezoid is that it has one pair of parallel sides. Now, there is an important implication to that, all right? Because I have two parallel sides that are cut through by transversals, I know that these two are same side interior angles, which add up to 180 degrees, and I also know that these two are same side interior angles that add to 180, okay? Notice all the tick marks are different because I can't say for sure that any of the angles is the same as another. When I'm dealing with a special kind of trapezoid though, okay, called an isosceles trapezoid, I actually have a little bit more information to work with, all right? So, what is an isosceles trapezoid? Well, it's a trapezoid, which means that it has parallel sides, as shown there, one pair. It also happens to have, kind of like an isosceles triangle, two legs that are congruent. Also, like an isosceles triangle, it's going to have what are called congruent base angles. What exactly do I mean by that? What I mean is that these two at the bottom are the same, right? Base angles, same. But triangles only had one base. These have two. So these angles up here by the other base are also congruent. Last but not least, an isosceles trapezoid actually gets, weirdly enough, one property from a rectangle. And that is that the diagonals are congruent. Okay, let me say that again. The diagonals are congruent. And if you want a fancy schmancy proof of why that is, you could do it using SAS, but we'll talk about that another time, okay? With that being said, let's take a look at page 16 so we can see a couple examples of what you might expect to see with trapezoid problems. The first example we're going to look at is example number 4. All right, example number 4. Okay, so this is actually just a standard trapezoid problem. And when I say standard trapezoid problem, what I mean is there's no fancy schmancy, congruent legs. It's not isosceles. So that's 12x plus 3, and this is 7x minus 13. Okay, so how do we do this? Obviously, these two angles are not congruent, right? That's obtuse. What we do know, though, is because I have two parallel lines that are cut through by a transversal, I've created same side interior angles. What property, going back to Unit 3, do I know about same side interior angles? They're supplementary, meaning they add to 180. Thus, if I add these together and set them equal to 180, I can solve for x. Let's go. So my equation is going to be pretty simple to set up, okay? Sorry. If only I could write correctly. Few of you guys, you have issues with like terms, all right? If it's on the same side of the equal sign, combine like terms first prior to doing inverse operations. So 12x and 7x together make 19x. Positive 3 minus 13 is minus 10. And look how nicely this is going to work out. When I add 10 to both sides, I get x equals 10. Now, sadly, if I were to put x equals 10, wrong. Why? Because in the problem, that's not what they asked for. In the problem, they asked me for angle R, which is right over here. So all we'd have to do then, all right, let me use a different color to show this clearly. I just take the 10 and substitute back in, okay? So in that case, I'm going to get 7 times 10 minus 13. That's 70 minus 13, which I believe is 57. So the measure of angle R is 57 degrees. Guys, when you're dealing with just plain old trapezoids, the most likely problem that you're going to encounter is involving same side interior angles. So if you have no idea what to do, probably add them up, set them equal to 180. All right. Ooh. Yikes. Sorry about that. Let's take a look now at example number 12, which involves isosceles trapezoids. All right. example number 12. And if memory serves me correctly, which is never, a certain thing, I do recall seeing something like this on your Unit 8 test from last year. Hint, hint, nudge, nudge, study, study. Okay? Now, they tell us that this is an isosceles trapezoid, right? Which automatically means that I know certain pieces of information, like I have two congruent legs. What's that? 6x minus 1. And 10x plus 5. Okay, now, in order to solve this problem, there are actually multiple approaches. Some people prefer to do this as a polygon interior angles problem involving n minus 2 times 180. Me, I don't know. I find that to be a little bit cumbersome, meaning like time wasting. So instead, what I want to do is I want to use a property of isosceles trapezoids. Namely, that they happen to have congruent base angles. Okay, let's think about how that helps us. If this is 6x minus 1, that means that this over here is also 6x minus 1. If this is 10x plus 5, this over here is also 10x plus 5. So now, my preferred course of action is to go back to same side interior angles. What do you guys know about same side interior angles? Like this, or, same thing, like this. What do they sum to? Or what do they add up to? They add to 180. So my equation, therefore, would simply be 10x plus 5 plus 6x minus 1 equals 180. Let's work that out. So 10x plus 5 plus 6x minus 1 equals 180. Let's combine some like terms. So I get 16x. I think it's plus 4, right? So check 4 from both sides, and I get 16x equals 176. How do I get rid of a multiplied 16? Divide both sides by 16. And I think it's actually 11, if memory serves me right. Now, of course, they didn't actually ask me for that. They asked me for the measure of each angle. Well, guess what? For this, I really only have to plug in twice because I know that the angles repeat. Like this one and this one are the same, and this one and this one are the same. All right? So just because I feel like it, I'll just plug in over here first. So 6 times 11 minus 1. 6 minus 1 gives me 65. That means that this over here is also going to be 65. So both z and y are 65. And if you wanted to, you could actually just subtract from 180 to find each of these. Or you could plug back in if you insisted, right? But you would find out that it's 115. So w and x are each 115. So isosceles trapezoid problems are actually not terribly difficult because you actually have a lot of information. And because you have a lot of information, it simplifies the equations that you're asked to do. If you had an example like example 10, where they actually give you the base angles, then you literally just set them equal to each other, right? And solve for x. By contrast, if they do something weird like this, where they give you like one base angle and another base angle, you could use properties of base angles to simply set up a problem with same side interior angles and go from there.